Hello students, this is the final part of our chapter, that is matter around a sphere, which is chapter 2. So let us begin our class. So in the previous class we were discussing about the separating the components of a mixture, in which we already studied about the method of evaporation, centrifugation, decantation and sublimation. Today we are going to cover these three topics: centrifugation, chromatography and distillation and fractional distillation. So in the topic chromatography, okay, the principle behind it is this method is used for separating the colored components from a liquid by using the filter paper and a blotting paper. So that means when you want to separate any colored mixture, or you can say any colored components in a liquid, this is very essential, colored component from a liquid by using the filter paper or blotting paper. So this process is called as chromatography. For example, they have given over here is put a drop of ink near one end of the strip of the filter paper and dip the end of the paper in the test tube containing the water. Can you see this one? This is the jar containing the water and this is the paper strip of the filter paper, and one line have been drawn over here, and this dot, can you see, this blue dot is the ink. And what they have done, the ink is the mixture of two or more colored components. Okay, so in this ink two or more colored components would be there. So this paper would be hung in such a way that a very small part of the paper is dipped inside the water. Okay, so once the paper is dipped inside the water, what will happen? The ink is the mixture of two or more colored components. The component which is more soluble in water rises faster and gets separated. So that means when this filter paper starts absorbing the water, and when the water reaches to this point, ink point, what will happen? The component which is mixed in the ink will rise faster, which is more soluble. For example, if this is the ink, blue ink, okay, and it contains two components, maybe called maybe the red one, maybe a red component, it is made up of a red component, and maybe one another by a purple component. So just take example like the red is more soluble than the purple one. So what will happen? Along with the water, it will start moving faster than the other one. So in this way we can separate the colored components, okay, depending upon its solubility. So here you can see this is the first filter paper. After some time, when the water is reaching here, you can see the color things that is getting separated. So if blue color has reached at the topmost level, that means blue color is more soluble in water, and this magenta or purple color is comparatively less, and this yellow color is very less soluble in the water. That is why it does not rise as fast. So if you will do this activity in your laboratory, you will get the strips of paper like this with different bands of the color. So now let's move on to our next topic, that is distillation. Okay, and this distillation method is used, or it can be used for separating a mixture of miscible liquids by boiling the mixture and cooling and condensing the vapors. Okay, so two miscible liquids can be separated by boiling process, then cooling it, and then condensing the vapors. Okay, so here they have given one example. It's like separating a mixture of two miscible liquids having sufficient difference in their boiling points, means, but the condition required in the distillation process is the miscible liquid should have difference in their boiling points. For example, they have taken one acetone, okay, and water. These two are the liquids, miscible liquids, okay, and when both the mixture, when a mixture of acetone and water is heated up, okay, in the distillation apparatus, okay, so this is called as the distillation apparatus. Okay, so when the acetone and water mixture is heated up in the distillation apparatus, what will happen? The acetone, which has lower boiling point, why? Because acetone can start boiling at lower temperature. So that is why what will happen, the acetone which has the lower boiling point than the water, it will boil first. That means the acetone will boil first, and then it will be cooled, and when it is boiling and then when it is cooled down, what will happen? We can condense it, okay, and it can be separated from the water. Can you see this one? Here you can see here the acetone and water were getting boiled. Acetone converted into the vapors, and once it was cooled, it turned into vapor. It condensed into it, and again it was separated from the water through this one. Okay, so this way we can separate the acetone from the water. So this process is called as the distillation process. So the next topic is the fractional distillation. Okay, and this fractional distillation is used for separating a mixture of two or more miscible liquids. Okay, so this also separates the miscible liquids, but it separates two even more miscible liquids also, and whose difference in boiling points is less than 25 K. Okay, so the boiling point should be always less than 25 K. K is Kelvin. Okay, so the apparatus used for the fractional distillation is similar to that in the simple distillation. So whatever the apparatus that we have used in the simple distillation, okay, it is similar to the fractional distillation. Okay, what is the exceptional over here is the fractional column is fitted between the distillation flask. Okay, so can you see this? Fractional column is fitted between the distillation flask. Okay, and the fractional column has a glass bend which increases the surface for the, can you see this one? Bend which increases the surface for the vapors to cool and condense. So this fractional distillation is used for separating the components of petroleum. So this is the one example when you have to separate the components of petroleum. We can do the fractional distillation and separating the different gases from the air. Even the gases can be separated out from the air. So how does the separation of components of air? Okay, so air is a mixture of gases, we all know, and the components of air can be separated by the fractional distillation. Just now we studied. So first of all, we need to know air is compressed by increasing the pressure, okay, and cooled by decreasing the temperature to get liquid air. As you all know, when we will increase the pressure on the air, okay, and when it is cooled by decreasing the temperature, it will be turned to liquid air. Okay, so the liquid air is then allowed to warm up slowly in fractional distillation. Okay, that means by increasing the pressure or by cooling it by decreasing the temperature, this liquid air is then allowed to warm up in the fractional distillation column. Then the different components separate at different heights depending on their different boiling points. So here you can see air is there. It is compressed or cooled by increasing the pressure or decreasing the temperature. Then it turned into the liquid air. Then this was allowed to warm up slowly in the fractional distillation column. And once it was allowed to warm up in the distillation column, what happened? As the gases had different, okay, so as the gases got separated at different heights because of the different boiling points. For example, the boiling points at degree Celsius, oxygen is 183, argon is 186, and nitrogen is 186. So depending upon these differences of the boiling points, even the components of air can also be separated up. So this is the another methods, purification of solids by the crystallization process. Crystallization process is also another criteria to purify or to take out the purified parts from the solids. So the crystallization process is of obtaining a pure solid in the form of crystals. So from the term itself, crystallization, you can say like the pure form of a solid can be obtained in the form of crystals from its solution. From a solution, you can get a pure crystals. So by crystallization, we can obtain pure copper sulfate from its solution. So this is the example from the copper sulfate solution. Okay, from the copper sulfate solution, we can get a pure form of copper crystals. Okay, so what do you have to do in this? Dissolve 5 gram of copper sulfate in minimum amount of water. Then filter the solution to remove the impurities. Then it is evaporated, or you can say it is heated up in the china dish to get a saturated solution. Okay, after that, cover the solution with a filter paper and allow it to cool. So after some time, what you will get, a pure copper sulfate crystal will be formed. Okay, so this is the impure copper sulfate, and after dissolving it in water, then filtering it to remove the impurities, then by heating it to prepare the saturated solution, and then covered with a filter paper solution and allowed it to cool, you will get this pure copper sulfate crystals, which will be very shiny. So till now we were talking about the mixtures. Okay, so now let's talk about the type of pure substances. What are the pure substances? So the pure substances are of two types, the elements and the compounds. So what is the element? It is the basic form of a matter which cannot be broken down into simpler substance by the chemical reactions. That means if there is an element, it cannot be further divided into further elements. Okay, so these can be a metal or non-metal or metalloids. So what are the properties of metals? So they have the luster, they're malleable and ductile, that means beaten into sheets, or they can be drawn into wires. They are good conductors of heat and electricity, and they are sonorous. Sonorous means which produces sound. So these are the examples of metals. What are those? Iron, aluminium, zinc, mercury, copper, silver, gold. So these are the examples of element. So iron cannot be further broken down. Is in the same way aluminium cannot be further broken down. So next one is the properties of non-metals. So what are the properties of non-metals? They do not have luster, they do not have shine. It means they are not malleable or ductile. Okay. Then they are the poor conductors of heat and electricity. They are not sonorous, means they do not produce a conjing sound. Okay. So what is the example? Hydrogen, oxygen, nitrogen, iodine, copper, sulfur and phosphorus. Next one is, what is the properties of metalloids? Metalloids are elements which show some properties of metals and some properties of non-metals. So this is the, apart from metals and non-metals, there is another category which shows some part of the metals and some part of the non-metals. For example, boron, silicon and germanium. So these are some examples. So now let's talk about the compounds. What are compounds? Okay, so compound is a substance composed of two or more elements chemically combined together in a fixed ratio. That means element was a single element which cannot be further broken down, but compound means it is made up of two elements but it is like combined together in a fixed ratio. For example, water, H2O. So there is two atoms of hydrogen and one atom of oxygen. Carbon dioxide, CO2, one atom of carbon and two atoms of oxygen. So in this way there is a fixed ratio in it. So they are called as the compounds because it is made up of the carbon and as well as the oxygen. So what is the difference between the mixtures and the compounds? Mixtures are, it is composed of two or more elements or compounds mixed together. And what are compounds? It is composed of two or more elements chemically combined together. Okay. And the composition of the components is in any ratio. That means the mixing can be in any form. Not like in compounds we have a fixed ratio. You can see over here the compounds have a fixed ratio, that means H2O. But when we talk about the mixtures, it is not like that. Okay, there will be no fixed like numbering of the hydrogen or the oxygen or the carbon or the oxygen. So in mixtures they can have any ratios, but in compounds they have the fixed ratios. And it shows the properties of components. Okay, and it shows the different properties than the components. The next one is, the components can be separated by the physical methods and the components can be separated only by the chemical methods. That means by the physical process itself we can separate the mixture, but for the compounds we need the chemical methods to separate it. So that's it about the chapter. So we are done with the chapter and we'll be meeting up in our next video with a new chapter. Till then, bye bye everyone.